types of triangles. Now, this is a right-angled triangle because here you have 90 degrees. Okay, this is a right-angled triangle. Let us suppose these are the three sides A, B, and C. These are the three vertices A, B, and C. Now this triangle has got three sides AB, BC, and AC. Now can you see here at a point B you have the right angle, 90 degree you have, and the side that is opposite the right angle. Which is the side opposite the right angle? It is AC. And as you can observe here, AC is the longest side, and this side which is opposite the right angle, AC is opposite the right angle, and this side is called the hypotenuse. It is called the hypotenuse, and that is the longest side in a right angle triangle. Now look at the other two sides, that is AB and BC. These two sides which contain the right angle are called the legs of the right angle, triangle. So in a right angle triangle, the side opposite the right angle is called the hypotenuse, and the other two sides are called the legs of the right angle triangle. Now, there was a Greek philosopher by name Pythagoras. He found out a very important and useful concept relating to right angle triangle. So today we are going to learn about this Pythagoras theorem. It is named after him because he has found out something very important regarding the right angle triangle. And so the theorem is called Pythagoras theorem. Now we see what it is. Now can you see the children? Here you have a right angle triangle. Can you see? A, B, C is a right angle triangle. Now in this triangle, here you have, this is the right angle. At the point B, you have the right angle. And the side opposite the right angle is AC. So AC is the hypotenuse. And these are the two legs of the right angle triangle. Now, here we have taken 3 centimeters. Here we have taken 4 centimeters. And here we have taken 5 centimeters. Now, on each side, we are going to draw a square. Now, this is 3 centimeters. So, this is 3 centimeters square. Okay, here it is 4 centimeters. This is 4 centimeters square. And here it is 5 centimeters. So, it is 5 centimeters square. And how many squares are there? You have 9 squares inside this. Here you have 16 squares. And here you have 25 squares. So we will see what is the relationship now. How they are connected. Can you see here? 25 squares. Here you have 9, here you have 14. So here we have, see there are 9 squares. Here you have 16 squares. So this and this together, 9 and 16. Together when you add you get 25. So these squares and these squares, 9 squares and 16 squares, when you put them together, when you find the sum, it is equal to 25. This is a very important concept which was discovered, invented, found out by Pythagoras. So we'll see how to write the formula. Now this is 9. That is AB square, the square of the hypotenuse. That is BC square. This is how we write BC square plus this square. That is AB square. The square which is on the other side. That is AB square is equal to, this is AC square. See 25. This one AC square. So it is AC square. So what is the what does the Pythagoras theorem tell us? Now, the Pythagoras theorem tells that in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Now, for example, we work out this sum. This is a right angle triangle. We name this as vertex A, B and C. A, B and C. Now, according to the Pythagoras theorem, the square on the hypotenuse. Now, AC is the hypotenuse and you have to find the length x. This length x you have to find out. It is an unknown number. Here AB is given as 6 centimeters and BC is given as 8 centimeters. Now, what does the Pythagoras theorem tell? The square on the hypotenuse. Square, that is AC square. The square on the hypotenuse. This is the hypotenuse AC. So AC square is equal to sum of the squares on the other two sides. These are the other two sides. That is AB square plus BC square. This is the Pythagoras theorem. Now we will substitute the values. Now AC square, this is AC. So the length is x. So x square is equal to, see AC is x. So AC square is x square is equal to AB is 6. So 6 square plus BC is 8 square. We are substituting the values here. Now we have to find out the value of x. So this is x square is equal to 6 square. Means it is 6 into 6. Don't multiply 6 into 2. No. 6 square means it is 6 into 6. 6 into 6 is 36 plus 8 square. 8 square is 8 into 8. 8 into 8 is 64. Okay. Now next step. X square. X square is equal to, we will add these two. 64 plus 36. 64 plus 36 is 100. Isn't it? So x square is equal to 100. So this is a square number. We will write this also as a square number. So we get x square is equal to 100 is 10 square. 10 into 10 is 100. So we can write this as 10 square. So x square is equal to 10 square. So how much is only x? X is equal to 10. Okay. So this length AC is equal to 10 centimeters. Children, now look at the second example. Now here look at this. ABC is a triangle. Right angle at C. If AB is 25 centimeters and AC is 7 centimeters, find BC. Now here they say ABC is a triangle. It's right angle. Okay, so first you must always draw a rough figure. Very important. You have to always draw a rough figure. You have to draw a rough figure of the right angle triangle. It's a rough figure. Now they say right angle at C. That means the right angle must come at the point C. Right angle is here and this point is C. Okay? And then they say if AB is 25, 25 is the lowest side. So this will be point A, this will be point B, and this is 25 centimeters. Okay? So AB is 25. Next they given AC is 7 centimeters. So AC is here. So this is 7 centimeters. Find BC. This you have to find out. This length BC you have to find out. Now since it is a right angle triangle, we are going to apply the Pythagoras theorem. Okay. Now coming to the Pythagoras theorem. The Pythagoras theorem tells us that in a right angle triangle, the square on the hypotenuse. Now here hypotenuse to find out. So we write it as it is. BC we have to find out. So you write it as it is. BC square. Okay, this we have to find out. Now you all know this is an equation. You all have learned about equations. Now we have to find BC. Now let this BC remain here. You have to take this 7 square to the other side. Okay. So you will get BC square is equal to 25 square minus, when it goes to the other side, 7 square, you have to minus. When it changes the side, you have to change the sign also. So 7 square will become minus 7 square. Now we will simplify. BC square is equal to 25 square means it is 25 into 25. 25 into 25 you have to multiply. You will get 625 minus 7 square is 7 into 7. 7 into 7 is 49. Okay. So BC square is equal to, now 625 minus 625, you have to minus 49. So 50 minus 9 is 6. 576. So when you subtract, you will get 576. Okay. So BC square is equal to 576. But you want only BC, isn't it? So again you get BC square. Now we will write this as a square number. This is a square number. We have to write this also in the form of a square number. 576 is 24 square. 24 square. So there's 24 into 24. 24 square. When you multiply 24 into 24, you will get 576. So 576 is 24 square. So BC square is equal to 24 square. But now we have to find only BC. So BC is equal to 24 centimeters. Okay, children, now let us look at the third example on Pythagoras theorem. So look at it. A 15-meter long ladder reached a window 12-meter high from the ground. On placing it against a wall at a distance A, find the distance of the foot of the ladder from the wall. Now you know a ladder, when we place it against a wall, the wall is vertical, straight, and we place the ladder like this. This is the top of the ladder, this is the foot of the ladder. Now we will draw a rough figure. Always we have to draw a rough figure. Okay, now this is the ground level. This is the ground level. Okay, this is the ground. And the ladder is being placed like this. The ladder is being placed against the, this is the ladder. This is the ladder which is being placed slanting. Okay, this is the ladder. Ladder is being placed against the wall. And the wall is vertical. Now this is the wall. The wall. This is the wall. And this is the ground level. So this is the ladder. Ladder is being placed against the wall. This is the wall. This is the foot of the ladder. This is the top of the ladder. Okay. Now the 15-meter long ladder. The ladder is 15 meters long. So that is from here to here. It is 15 meters. 15 meters long ladder. Okay. Reach the window. The window is here. 12 meters high from the ground. From the ground it is 12 meters. That is from here to here it is 12 meters. From the top to the floor. To the ground it is 12 meters. This is the wall. This line represents the wall. This represents the ladder. This is the ground level. Okay. So they are saying at a distance of A. This is A. They are saying this is A, which you have to find out. What is the distance from the foot of the ladder to the wall? This you have to find out. See, find the distance of the foot of the ladder 25 minus 12 square is 12 into 12. 12 12s are 144. 144. Okay, so we have a square is equal to 225 minus 144. See, 225 minus 144. 5 minus 4 is 1. 12 minus 4 is 8. 81 unit. Okay, so a square is 81. When you subtract, see, you get 81. Okay. So this is a square number, children. You must write this also as a square number. So you will get a square is equal to 9 square. Don't know? 9 into 9. 9 nines are 81. So 81 is 9 square. So a square is equal to 9 square. So a is equal to 9 meter. So the distance from the foot of the ladder from the wall is 9 meters. So here we have to write, therefore, the distance that is A. The given A or distance A. So the distance A of the foot of the ladder from the wall is equal to 9